Hello everyone. Today we are going to discuss about a logistic regression algorithm. It's also a simple algorithm used for classification problems, and we are going to implement end to end in Python. So similar to linear regression, where if you remember we were trying to draw a line on the data, this is also similar. However, because it's a classification problem, we have two sets of output, either 0 or 1. So our line needs to be inside that data set. That is why we use a sigmoid function to convert our linear regression output into an S curve. So you will better understand when we see this. So if, as I said, we're trying to do a binary classification problem where we are trying to decide if a customer will buy a product or not. If he will buy, it is 1. If he won't buy, it is 0. Right? So once we do our machine learning, what it would learn the W and B parameters of the algorithm. With that, we can able to plot a sigmoid curve on the data. So it's very similar to linear regression, but I think the naming could have been better. We could have called it sigmoid classification, because at the end we are trying to put a sigmoid curve on the data, and it's trying to classify between the data rather than a regression problem where you are trying to predict a number. So the formula for logistic regression is, first we do a linear regression, or we try to plot a line, then we pass it through a sigmoid function which is responsible of converting that line into a S curve between 1 and 0. Okay? And for today's example, we are trying to create a simple logistic regression which will have a fit and a predict method. Okay, so let's get started. So for our understanding, I have created the class and the different methods which we need. So same like linear regression, we will at the end, the goal is to find the value of W and B, right? So the one thing which you would see new is a sigmoid function. So maybe let's try to implement that. So sigmoid function is return 1 by 1 plus, we need our import numpy as np. So for the exponential, we are using numpy numpy.exp of here our z, right? So this is the function which is responsible for converting our line into an S curve within zeros and ones. Next, let us implement our init, which is similar to last time. Self.w is equal to init of w, self.b is equal to init of b. And this time we have two predict methods because we wanted to see the prediction as a number. The predict proba is going to give a probability between 0 and 100. That is because we are trying to compare it with our previous implementation, right? So the scikit-learn implementation. So if you want to see if the values are similar to that, I thought predict proba would be easier to understand. Then let's go for our fit. Fit is similar. We iterate through epoch or the number of times you want to train. So for I in range of epoch, what happened? Okay, here what we are trying to do is let's see, we want to find DL, DW as well as DL, DB, which is our values for derivatives, right? And for that we are going to use the compute gradient, and we have to pass our x, y, as well as self of w, as well as self of p for it to find. And once it finds that, we are trying to update the value of w, right? dl dw minus, so every time we are trying to minus, sorry, self of w minus learning rate into our derivative dl dw. Similarly, self of p is equal to self of p minus lr into dl dp. We could compute the cost and print it also, so let's see, maybe should we have print cost, so we'll compute cost. Actually cost we are not using for the gradient descent, but just for our printing. And the same way the cost also needs x, y, w and b. The cost function here is little different because it's a logarithmic value, and we will come to that compared to our linear regression. Okay, so we have defined that, for I in range, my bad. We could even have given underscore because we don't care what is the value of I in this iteration. Okay, so we have completed our fit, which is used to train our algorithm, and whenever we say train, it's trying to update w and b on a small scale, right? So the predict pretty much same like the last time, y, okay, equal to self of w into x, right, plus self of b. Now the thing is, here we want to have the prediction between 0 or 1, right? So for that we can say if y greater than 0.5, return 1, else return return 0. Now coming to our gradient function, same like last time, we will have a m, which is the length of x, which means we want to iterate over each values of our data, right? So this is our data. We will have some age values, the income and the purchase. So for our simple logistic regression, we are only taking the age, okay? And this is the value we are trying to predict, 0 or 1. Okay, computing the gradient, so yeah, dl dw is equal to 0, dl db, which we want to return, is also 0, for I in range of m. So fwb is equal to, first, like, let's see, f of fx of I equal to same w into x of I plus b. Now we want to f of z equal to sigmoid, right? This is where our sigmoid comes. We're going to pass the fx of I into the sigmoid, and with that we have f is z. Now what is the error? It is the difference between the actual prediction, which is y, versus f of z minus y. So we got the error. Now we want to do that small step. dl dw of I is equal to error of I into x of I. Similarly, for dl dwb of I is equal to error of I. This is our b parameter is not dependent on x of I, right? Then finally we are updating dl dw plus equal to dl I. Similarly for dl db plus equal, and finally because we are iterating through m data set, we have to divide by m, right? dl dw equal to dl dw divided by m. Same thing, dl db equal to dl db by m. And we got our derivatives, which we are going to return. So return dl dw comma dl db. Perfect. Now we also need to compute the cost. So this is where I was saying the cost function is little different, and let me see, the cost for a sigmoid function, I mean the logistic regression, is this one. For the time, I'm just copying that, and so let us first start by defining our values, right? So same like m is equal to length of x. We want to find the cost, so total cost equal to 0 first. Then for I in range of m, again for each of the values we are planning. So for now, to make it easy, I'm going to apply the sigmoid also on the same line, w into x of I plus b, right? And then the total cost is the formula which we took, is a logarithmic value. Basically there are two parts, the first part and the second part. Ideally this is only one area, but based on the value of I, either 0 or 1, either this part of the function gets activated or this part of the function gets activated. Okay, then we will say total cost equal to total, again divide by m, and return total cost. So that defines most of our functions. And one interesting thing here is the predict proba, which is, like we said, similar to this, but we are trying to predict if the number is the percentage, right? So for that, first we got this value, and y predict is equal to sigmoid of that y, right? Then what we are doing is y other, or the second part, because it's a binary 0 and 1, right? So if this is a prediction of 1, what is a prediction of 0? So that is 1 minus y predict. Then we are creating a response which is both of these values together. When you run the scikit-learn version of this, you will understand always predict proba gives two values. One is the probability of 0 as well as 1. So response dot append, first we put then response dot append predict return. Okay, so with that we have implemented a simple logistic regression, and we can go through and try it out with an example. So simple logistic regression, let me clear all the output. So like we discussed, we are taking this data set where it is loading the purchase as well as the age as well as a purchase, right? And now first, this is our implementation of logistic regression. We are giving the initial values as 0 for W and B, and we are trying to train it for 10,000 epochs with a learning rate of 0.03. So if we can see, our cost is reducing, which is good. We could have maybe given a lower value for cost and tried with a different learning rate. Feel free to try it out whenever you are using this. This code has been uploaded to GitHub. So finally, let's try to plot our cost. So we can see our cost is reducing. Now let's use scikit-learn's library to implement logistic regression. That's our comparison, right? And again, if you see our x, it is only age, and y is our purchase, right? Yeah, logistic regression algorithm is built. We will try to print both of our values. So our model had a w value of this and this, which is similar to what their scikit-learn algorithm also had. So let's try to predict for one value 80 and 0.19, 82, and finally we will try to plot our sigmoid curve. So yeah, we had almost same sigmoid curve as the scikit-learn library. So I think we had a very good implementation. All this code would be uploaded, and we also have a multi-logistic regression implementation where we will take more than one feature, right? So give it a try. Thank you.